So when we have these 4 quantum numbers, we're talking about that probability map based upon those values for psi. So let's start getting into each of those 4 quantum numbers. Now there really are 3 quantum numbers and an electron spin. The 3 quantum numbers are more for the orbitals. So the first quantum number is the principal quantum number, or the n, which is the rho. Okay, so this would be just a value, an integer between 1, it would just go 1 and up. Basically, if an electron gets excited, it can go even to higher energy levels. Cannot be 0. We do not have a 0 rho. The second quantum number is L, which is the azimuthal quantum number. And this value is related to the blocks, the SP, D, or F. And it gives more of the shape. The SP, D, or F is actually the shape of the orbital. So here we have the SP, D, or F. And you can see, and I think we might get into later, but S would be like a sphere, the P are more like dumbbells, the D looks like a flower, and the F is crazy. The L being azimuthal, you don't actually have to know for the test, but I'm going to keep referring back to it. You will have this PowerPoint on the website in case you need to reference back to it. So S is 0, P is 1, D is 2, and F is 3. So that's the value of L, which is the second quantum number. The third quantum number is the magnetic quantum number, and this describes the 3-dimensional shape. So if you put up an axis, where would it be? Well, for the magnetic quantum number, it's based upon which block it's in. So it can go from negative L to positive L, which means that if it's in the S block, which its L number is 0, it's just 0. There is no other third quantum number, just 0. If it's in the P block, its L, or azimuthal, second quantum number is 1, which means it can go from negative 1, so if I write this up here, it can go, so we're talking about P, okay, it can go from negative 1 to positive 1, right? D, which is 2, can go from negative 2 to positive 2, which I drew a little bit in class. All right? Sorry about the overlap there. So you can see they're saying the same thing. You can go up to the 7F orbitals, negative 3 to positive 3, because the number for F in the second quantum number, the azimuthal quantum number, the L quantum number for F is 3. So you can see a lot more of that right here. Now I drew a pyramid, which is a lot easier to read, but that is basically what's happening here. Orbitals in the same N, and N is a rho, it's an energy level, okay, it's a shell, okay? And that means that the different subshells are, the different orbitals within each shell are the subshells. So these are each subshells, okay? So you can see that if we're in 4, okay, so the first quantum number is a 4, and let's say that you are in the F block, that means the second quantum number is a 3, because the azimuthal quantum number for F is 3, and your possibilities go from negative 3 to positive 3. All right? That means that's your third quantum number. It could be, I'm going to write negative 3 greater than or equal to the third quantum number, the magnetic number for the L, and all the way up to or equal to the positive 3. So whatever that third quantum number is. The fourth quantum number is the magnetic spin, easy enough, positive half or negative half. So I think there's a little bit in here about shapes. The S, you can see it's spherical, not a big deal. I think there's more in here that you can read later. P, you've got these, it's gonna, if you put them all together, it's going to form more of the dumbbell shapes. The D, you've got more of the flower, but of course, make sure you take a look here. You've got one with a donut in it. Do you need to know that for the test? No, but it might help you a little bit. Here's the spin, and of course, as I mentioned before, that they can be negative half or positive half. And that's it. Those are the 4 quantum numbers. Well, the next question is, well, how do we apply this? So here's a nice blank, empty periodic table. This is the S block. This is the P block. This is the D block. And down here is the F block. Okay? Now, that means that the rows, which right here could be 1, 2, 3, 4, 5, 6, 7, right? So we have our rows they can be. Now remember, D is n minus 1. So its number, its first quantum number, if you pick an element in this area right here, its first quantum number is actually going to be n minus 1. If you pick F, it's n minus 2, or not pick, if you're given that. Right? So then the second quantum number is the block, or the subshell. So for D, of course, that would be 2, right? S is a 0 quantum number, P is 1 for a quantum number, D is 2, and F is 3. Well, still, again, you guys are fine. You guys understand that part. Now let's get to the third quantum number, because the third quantum number is what really messes people up. Here's a quick and easy way, and you can just say, hey, this is the way that it's done, if it makes it easier, okay? So everything that's in the first row, okay, this is the 0 orbital. Everything in the very first column is a positive half. Everything when it goes into a second column is a negative half. Okay, so the first electron into a block, into a square. Remember how we do this box right here? The first one in, the first arrow, the first electron that goes in is always a positive half. The second electron that goes in, going down, is a negative half. And I think that will help a little bit. So we've got the 0 block, the 0 orbital, positive half, negative half. Okay, if it's in the P block, you could say that, and I'm hoping this will be easier for you to recognize, that because of Hund's rule, you have to put 1 electron in each orbital before you can add a second one, which means that this column right here, everything in this first column is in the -1 orbital. Everything in this column right here is in the 0 orbital. Everything in this third column is in the +1 orbital. And because they're the first electron into this, and I'm sorry about, probably good of me to say where I got my graphics from. Everything in these first 3 columns is the first electron in, so these are all positive half on the spin, which means these are all the second electron in, which means these are all going to be negative half. The second one into -1. Everything in this column is going to be -1. Everything is going to be 0. Everything in this column is going to be +1. And I'm hoping maybe you can see a pattern. Same thing's going to happen again in the D. D is the second. Its azimuthal quantum number, its second quantum number is 2, so its third quantum number can go from -2 to +2. -2, -1, 0, +1, +2. Start over again for the second electron into the block. -2, -1, 0, +1, +2. The first 5 are the first electron in. These are all +1/2. These are all the second electron in. So these would be -1/2. Okay? I'm going to do these really quick for the F. Now we can go from -3 to +3. -3, -2, -1, 0, +1, +2, +3. Okay? These are all the first electron in, so they're all going to be +1/2. On the other side, you have -3, -2, -1, 0, +1, +2, +3. And this last block, there's some debate over what it should be. It's a transition between the lanthanides and actinides. And so it's just know that it's not really going to be something that you're going to have to do anything for. So we're just going to end up scratching it out is what we're going to end up doing. Anyways, those last 7 blocks are the second electron, so it's the -1/2.